we're looking at the idea of work in physics. So in physics, work is said to be done only for certain set of condition. Whatever we traditionally think that we did, like I sat and I just thought, I thought about few numericals. I was thinking about deriving a plus b the whole square, right? I don't have a pen or a pencil, but I derived it in my head. So some might say that yes, I did some work, but in physics, it's not so. So in physics, the idea of work needs to satisfy certain condition. Now, the basic idea is that work, out of all the effort you put in, this, that is the work, is part of that actual counted. That's actually counted. Say you put effort. Like if you put effort and there is no result, then we have no work. So what does this no result mean? You know? So that is again something that we need to understand. So basically, work is a measure of energy transfer that occurs when an object is moved over a distance by an external force, at least part of which is applied in the direction of the displacement. I'll explain that part. So let me go to a Python code. So basically, let's make use of a simulation. Okay, yes. So just let's concentrate on this. Now I have an object. I have a force. I can vary the force, strength of the force. Okay. Right? If I apply the force every second, there's certain displacement. Oh, there's friction also. Oh, work done force with friction. Sorry, that's why it's stopping. Now, same thing, same force, but I'll change the angle. Right? Okay, first is let's have a benchmark. So let me have some decent force. Then if I happen to just push it for a second, so it reached a distance of 10 meters. Let's consider it meters. Now the same force, right? Look at the vector. It's not length is not changing, but the angle is changing. Okay. Then actually, now if I apply the force, let's see what happens. Last time I reached what distance? 10 newtons. Now how much am I reaching? Yes, less than 10. If I change the angle further, let's see. I just took a step, a small step. That's it. Then if I change it to 90, so you'll see that the object won't move. Yes. Oh yeah. By the way, you might be thinking that yes, why is that the object not going up or anything? You know, imagine that this is a ball on the ground or a very heavy object on the ground. We can just make it move left or right, forward or backward, not up and down. So angle plays an important role, is it not? Right? So let's go back to the statement. So if that is kind of commonsensical, work is a measure of energy transfer that occurs when an object is moved over a distance by an external force at least part of which is applied. Okay, this could have been typed properly. So at least part of which is applied in the direction of the displacement. Right? So if I happen to apply a force and if it moves, but it is moving because of some other force, my work will not be counted. I'll give you guys a best possible example. This is easy to understand and it is in front of you guys. Say I have a box and this is on a table. See, one force that is acting, even if you guys don't want, is gravitational pull. if I happen to make this guy move, right? He's here. And if I make him move from here till here, right? So the question is, who did the work? Did I do the work? This is my work. Sorry, this is my force. Right? So the object moved from point A to point B. It moved from A to B. Now the question is, who did the work? Or let me ask in another way. So object moving from A to B is the result of what? Is it mg force or fm force? It's result of fm. Right? Gravity is pulling down. But something moving left and right, it's because of another force and not gravity. Do you guys agree? So just because force is there and just because displacement is there does not mean that particular another or any other force has done some work. Here we got to see, here we have object getting displaced, but mg has no role in it, right? So as a conclusion, we can have work done, we can have force, but that force might not have done any work. So in physics, work is done only when you see it contributing to some kind of output. Out of all the effort you put in, the work that is part of the actual, the result is part, if there is a result, only that is part of the work that is considered. Mathematical, how it looks like, we'll discuss that. That also helps understanding all of this. So if you put an effort and there is no result, gravity is putting effort, right? Gravity is pulling it down, but there's no result. There's no displacement along the vertical direction, and then there's no work there's no work done as per the vertical direction, as per the gravitational pull. So there's no work done by gravity. Okay, so work is a measure of energy transfer that occurs when an object is moving over a distance by an external force, at least part of which is applied in the direction of the displacement. Again, this statement can be better. So sometimes, if I happen to do this, right? If I happen to do that, so not every amount of energy is transferred, all the force is transferred to the displacement along the horizontal, right? Clearly the same force, but if I do this, right, you can see it will get displaced more. Again, this amount of force is applied only at 0, and after that it disappears. Okay, so it's like hitting a striker. So once you hit the striker with your finger, it moves, and if friction is more on that surface, it will stop after a certain distance. So if I change the angle, what happens? Clearly the same amount of force, but the amount of work done by it will be different because the angle changed. So that's what this statement means. Okay, so that's about your work definition. In terms of formula, vector form, it's a dot product in rectangular form. So let me write it. So work can be force times of displacement, or FD cos theta Then you have work is equal to force along the x-axis I cap plus force along the y-axis j cap. If it's 2-dimension, you can go with this. Dotted with displacement, I'll write it as x I cap plus y j cap. Okay, so these are your, of course, we can further resolve this and you will get fx x plus fyy. Again, you need to understand vectors to understand this result, right? Both the results actually. If not, you're not doing you won't learn anything after this. So it's numericals and you guys will blank out. SI unit of work is same as energy, joules, dimension. Okay, you guys can do that. Defining 1 joule of work. So how do you define 1 joule of work? So again, whenever you have to define any SI unit, you have to go to the formula. 1 joule of work is said to be done if a force of 1 Newton is applied and we see a displacement of 1 meter. Right? So 1 joule of work is done when a force of 1 Newton is applied to an object, causing it to move a distance of 1 meter in the direction of the force. So that is the proper, actually that's proper definition. I missed out the last part, in the direction of the force. Again, you might be applying force, but the displacement can be in some other direction altogether. So that won't help us. It has to be in the direction of the force. At least in some degree. Okay. So this is something new that you will understand as and when we go. Nature of work can be differentiated as positive, 0 and negative. Positive work, okay, let me explain this way. In this diagram, our direction of displacement is to the right. This yellow color shows that. If my force is anywhere between this plus 90 degree and minus 90 degree, like example 1 and 6. So anywhere in this space, if the work is present and the displacement is to the right, then all of those force have said to have done positive work. But if the displacement is to the right and the force is up, exactly up 90, if not minus 90, then the work is said to be 0. Displacement is perpendicular to the force, then the work is said to be 0. That example is over here. Gravity is down, my displacement is to the right. They are perpendicular to each other. So gravity has done no work. Okay, even though the object has got displaced, gravity has no work done. But if I see a negative, if I see a force in the opposite direction but the displacement is to the right, then the set of works are said to be negative work. For example, so this is an example of negative work. Say you have an object, right? You threw it up. It's going up. So one force that is acting by default is your gravitational pull. But it's going up. So it's got displaced from say here till here. Displacement. So in this case, yes, this has done negative work. Your gravity has done negative work. So whenever you see object going away from the surface of the earth, Earth's gravitational force has done negative work. Positive work will be other way around. So we have the object, it's falling towards the ground, and I see the object getting displaced from point A to point B. If the displacement is in this direction, then the gravity, right? Direction of gravity is over here. Gravity is pointing downwards. Displacement is downwards. Now the gravity has done positive work. Okay. Right, guys. So key things to note over here is anywhere from 0 to 90, the opposite also, not including 90, positive work. 90, if not negative 90, it is 0 work. Anything post 90, from plus 90 to minus 90, actually in this space, but the displacement is the in the other space, then our force is said to have done negative work. Okay, so I think that's it. So please pause, copy this off.